This project is sponsored by PCBWay. Visit the PCBWay website and save big with a time-limited promotion on purple solder mask. From September 1st to September 30th, you can get 10 pieces of 2-layer 100 on 100mm PCBs in purple for only $5. PCBWay has all the services you need to create your project at the best price. Hello? Software-defined radio, or SDR radio, is a radio communication systems where components that have traditionally been implemented in analog hardware, such as mixers, filters, amplifiers, modulators and demodulators, are instead implemented by means of software on a computer or embedded systems. The biggest advantage of SDR is its flexibility. Because the functions are handled by software, you can change the radio's behavior by simply updating the software. This time I will present you a wonderful example of how to make such a receiver using Raspberry Pi Pico. Even this receiver works completely independently without the use of a PC, and all functions are controlled directly on it and displayed on a small OLED display. The original project is presented on the 101 Things website, and the author is Jon Dawson, so all credits go to him. Also, there are many more excellent Raspberry Pi Pico projects on this site, and I hope to test and promote some of them in the near future. The receiver consists of a minimum number of components, but its huge number of functions and possibilities for various settings, and can rival even expensive commercial devices of this kind. This is what the complete device looks like, made on a universal PCB, and as you can see, the layout of the components is almost identical to the breadboard version of the schematic presented on the source page. I made the complete PCB in less than a day and was positively surprised by the fact that the device worked immediately upon first powering on. Just a few words about installing the code. The GitHub page provides binaries for the Raspberry Pi Pico and the newer Raspberry Pi Pico 2 in the form of a UF2 file. This means that the installation is extremely simple. This is my PC desktop. Now we need to hold down the button on the Pico and plug the USB cable. Now the Pico, as we see, is presented in this PC as mass storage device, and we need to simply copy provided UF2 file into it. This is Pico RX UF2 file. Copy is complete. With this, the installation of the code on Raspberry Pi Pico is complete. Now comes the first power up of the device and a short test. I connected the audio output from the receiver to the line input of the PC sound card, and for now I connect a simple long wire antenna and try to receive a broadcast station to confirm the functionality. I will try to find any station. This is what the finished Pico SDR receiver looks like, placed in a suitable housing with the display and control buttons of the front panel and the power and antenna connections on the back. If we look inside the box, we will see that in addition to the universal PCB, it also have a D-class audio amplifier module along with a small speaker. So the SDR receiver is completely independent, keeping in mind that instead of an external power supply, we can install here lithium batteries with charger circuit. Now I will just briefly walk through the menu to look at all the functions and possibilities. To explain all these functions individually would take us a really long time. At the end of this text is the original manual according to which you can study all the functions in more details. For setting the options, we have two buttons, back and menu, plus Rotary Encoder with built-in button. When turning on the receiver, the display shows the information that has been saved since the last operation. Even at the start on this small display, it has many useful functions. In the middle is shown the current tuning frequency with large numbers. Then the demodulation mode, in this case AM. Next, battery status, signal strength in decibels, signal strength in the form of a bar, as well as the tuning step. By pressing the left button, we move through several interesting display modes. With first press, we go to spectrum display, then spectrum plus waterfall, next just waterfall, then data about the battery and resources of the microcontroller. Next come a beautiful analog signal strength meter. Schematic of a simple detector receiver as a screensaver. And finally we return to the home screen. With the Rotary Encoder, we set the desired frequency with a tuning step that we can also adjust. We can increase or decrease the frequency. By pressing the rotary knob, we enter the menu where we can select the appropriate band. By pressing it again, we activate the selected band. With the right menu button, we enter the main menu where we can perform detailed settings of the received signal. With the Rotary Encoder, we move through the menu and select the set value, and by pressing it again, we confirm the selected value. In the main menu, we have the following options: frequency, recall of stored data, frequency storage, then volume value from 0 to 9, Next, mode. We can choose between AM, AM sync, LSB, USB, FM, CW, and again AM. Then AGC speed, normal, slow, very slow, and value in decibels. Next, bandwidth. Then squelch option. Auto notch filter. We can choose between on and off. Next, de-emphasis. IQ correction. Also we can choose off or on. Off or on. Band start and band stop for scan function. Frequency setup, CW tone frequency, and finally hardware config. We also have more additional functions and shortcuts by pressing the three buttons in combination. While working on the project, to my great surprise, I accidentally noticed that this small SDR radio even has the option of an additional larger color display that shows the spectrum with a waterfall. The code already supports this option and we just need to add the additional display to the menu. I'm currently using the case with the display mounted from a previous project of mine, but it would be even better if both displays were mounted in a larger common case. With this visual addition, this beautiful little radio becomes even more attractive. This is the diagram for connecting the display with a Raspberry Pi Pico, and I did it with a soft flat cable. So this is the connection between display and Raspberry Pi Pico. Now we need to enable second display in the hardware menu and set the rotation and color. In menu, hardware config, we search for TFT settings, enable, we need to set rotation. In my case, that is rotation 5. This is nice waterfall and spectrum display. You can also change the color. Next, I will demonstrate the reception of broadcast stations and amateur radio communications. For this purpose, at certain times, I will use this simple antenna tuner placed between the antenna and the receiver for better reception, because the SDR receiver, at least at this stage of development, does not have appropriate filter circuit at the input.
deposita sus huevos en los arroyos, los peces que sobreviven a los depredadores, como las gaviotas habitantes, el lago van el resto del año repiten el viaje próximo. Llevan la memoria fiscal, la identidad ecológica y el sustento económico de una región. Para celebrar esta rara maravilla natural, el de final, câteva date financiare. Prețul euro este cotat la 5,0711.
And finally, a short conclusion. I really have no words to describe this great project. I thank Jon Dawson for the hard work he put into it, and I hope that in the future, with the support of the community, this project will develop even more. This project demonstrates the incredible potential of software-defined radio, transforming a few simple components into a powerful and flexible communication tool. I encourage you to build your own and explore the world of radio in a whole new day. It's truly remarkable to see how a simple Raspberry Pi Pico with a bit of code can unlock such a wide range of radio functions.